Okay, so hopefully we all have our notes packet out, and we should be on 5.4, which is on page 10. We'll start with that. And basically we are trying to learn new ways to find the area of a triangle. It's not like we have never calculated the area of a triangle. We have done area of a triangle, but we have always done area of the triangle using area equals half base times height. I hope this formula is familiar to you. This is what you guys have been using to find the area of a triangle from your middle school days, right? So the basic area of a triangle is area equals half base times height. Use this when you know the base, which is one of the sides, and what's important is the height. If you don't know the height of the triangle, you will not be able to. The base is easy to find because one of the sides. It's the height. The height is 90 degrees to the opposite side. Now the height is 90 degrees to the opposite side. So basically, how do you find the height? So if you have this triangle, let's say the height. So let's say this is your base. The height will be from the opposite vertex. You drop a 90-degree line. A height is always this. It's another word for height is altitude. The altitude is of any shape is always from the vertex. You drop a perpendicular line to the opposite side. But what happens if you don't know this height? What happens if you don't know this height? So this height almost creates like a right angle situation, right? It has to be, the line has to be right angle. If you don't know that, we use there are a couple of other formulas, and one of them is the first one we're going to look at, area of an oblique triangle. In this scenario, we do not need to know the height. We do not need to know the height. What you do need to know is you need to know the two sides and an angle in between. It says use this particular formula. There are two formulas actually that you will use to find the area of an oblique triangle. The first one is just called a regular area of an oblique triangle, and the second one is Heron's formula. The first one you do when you have the information that's given to you is SAS, and I'm going to just go ahead and just discuss this formula, how it's written, so that you'll understand why it's SAS. So area of a triangle is just like half base times height. It is half, but instead of base times height, it's half multiplied by the multiplication of the two sides. A and B are the two sides. And what is C? Capital C will be the angle between the two sides. So you can take any two sides. If you take B and C, A is the angle between B and C, so then half BC times sine A, or if you take A and C, you will take angle B, which is between the two. So that is why the information that you need is two sides. It doesn't matter which two sides, any two sides, and the angle between will allow you to use this formula to find an area of an oblique triangle. Okay, so for this you need to know SAS. For the other formula, called the Heron's formula, you will need to know all three sides. SSS. Okay, what I'm going to do is I'm going to go flip to the last page which contains the formula, because this sheet contains both the formula. So we have already done law of sine and law of cosine. We've done this, right? Law of sine, I'm sure it looks really familiar. Law of cosine looks really familiar. What's new is the other two formulas which help you to find the area of a triangle. So area of an oblique triangle is what I just introduced. That's the one that said half multiplied by the two sides and the angle in between. So this is the formula you will use when you have two sides and an angle in between. And the other formula you will use when you have all three sides. Why all three sides? Because remember, sides of a triangle are called A, B and C. So if you're given A, B and C, you will use this. And there's also an S, and we'll talk about that in a minute. But right now you will use the Heron's formula when three sides of a triangle are given to you. So these are the two scenarios for which you have a formula. And we'll also see scenarios when you don't have SAS or SSS, but you can get there. Okay? So let's go back to our notes. So Heron's formula is when you have all three sides given to you. So if you look at this formula, it's square root of S minus A, S minus B, S minus C, all three are multiplied. So I see an alphabet called S. Where S is, I'm going to write down what it is, and then you guys will tell me how do you find S. It is semi-perimeter or semi-perimeter, whatever you may say it. S stands for semi-perimeter. S stands for semi-perimeter. Bless you. Okay, so the question now is, what do we mean by semi-perimeter? Semi-perimeter is basically semi or semi always means half. Semicircle is half. So it's half. So first of all, I want to ask you, do you guys know how to find the perimeter of a triangle? So here we're talking about a triangle. So how do you find the perimeter of a triangle? I have all three sides. Remember, I have SSS. I have the measurement of A, measurement of B, measurement of C. So for me to find the perimeter, what do I do? Alright, everybody should know the answer to this. How do you find the perimeter of any triangle? Add all the sides. So basically it's going to be, perimeter is nothing but A plus B plus C. Oh sorry, you can't see. We're okay? A plus B plus C gives me the perimeter. But it's not perimeter that I want semi-perimeter. That means half the perimeter. So all you do is, you take A plus B plus C and divide it by 2. That's my semi-perimeter. So please remember this, you need this to use in the formula. So if you see the alphabet S, you should connect that it is a semi-perimeter, and all of us should know how to find the semi-perimeter. Because for a Heron's formula, you basically work with all three sides. All three sides of a triangle are given. Whenever three sides of a triangle are given, you can always check if it is a valid triangle by using triangle inequality theorem. I introduced this a little bit last class, saying that you guys have seen this in geometry. Triangle inequality theorem is, take the two small sides, add them up. S1 and S2 are the two small sides of the triangle. They should always be greater than the large side. You guys remember this? And we talked about this last class, that in any given triangle, given three sides, for you to check if this is even a valid triangle, take the two small sides, add them up, they should be greater than the large side. Let's go ahead and they're asking, do a quick check for these triangles, A, B and C. How do you check if 2, 3 and 2, whatever the units are, let's say it's 2 inches, 3 inches and 4 inches. How do you know a measurement of 2 inches, 3 inches and 4 inches if you can form a triangle? We have to take the two small sides. What are my two small sides? Should be greater than 2 plus 3 is 5. Is 5 greater than 4? Yes. So I can form a triangle with 2 inches, 3 inches and 4 inches. Can we all do a quick check for B and C? Can you form a triangle with 1, 2 and 3? Can you form a triangle with 1, 1 and 3? One plus 2 is equal to 3. Remember, it has to be greater than. Equal to also does not work. So I cannot form a triangle with 1, 2 and 3, and 1 plus 1 is 2 is definitely not greater than 3. So I cannot form a triangle with my situation in B and C. Alright, everybody good? Alright. Now what we're going to do is, we are going to find the areas in these 4 scenarios. So number 1. Can I go? Everybody okay? Number 1, find the area of the given triangle for these problems 1 to 4. Number 1, I have been given a triangle with two sides. These are my two given sides and the angle in between. So what kind of a situation am I in? I have two sides and an angle in between, correct? That means I will use my first formula. Can we all use the first formula and set it up and find it? I don't think you need my help. Okay, that should be your statement. Half times the two sides multiplied by the sine of the angle in between. Multiplied by the sine of the angle in between. The only thing is you want to make sure. Yeah, no, this fine. There's nothing to make sure. I can put this in the calculator. Just one thing that to make your life simpler to put in the calculator. Half and 2 simplifies. So you don't have to say half of half times 2. So this 2 simplifies. So all you have to put in the calculator is 5 times sine of 20, round to 3 decimals, and that's your area of this triangle. Is everybody clear? Yeah.
Are we going to have the formulas for the code?
Yeah, you are. Yeah. And whenever they give you the unit of measurement, you should always write the unit of measurement in the final answer. I will take points off if you don't do that. Yes, so the area is 1.71 centimeters square. Please use your calculator. Make sure you got that before we go to the next one. Yes. Did you have a question? For if you don't write, give me the unit of measurement.
Oh.
Not all points, but I'll probably take like half a point or something like that. Is everybody okay with 1? Do we need a little more time? Can you raise your hand if you're still putting it in your calculator? No, okay. Then let's go to 2. What do you notice in 2? I have been given all 3 sides. So it is basically SSS. That means which formula am I using? We're using the Heron's formula, correct? Because of SSS is Heron's formula, and SAS is the first formula, area of the oblique triangle. So here, because all 3 sides are given to me, I use the Heron's formula. In the Heron's formula uses the small s. We have all the 3 sides, A, B and C, but it also uses a small s. First step in Heron's formula is to find the small s, which stands for the semi-perimeter. Please find the small s and then use your formula to solve for the area. So let's go ahead and finish this. Again, you don't need my help. It's just using the formula. Okay. Please go ahead and use your calculator and finish it up. Okay, okay, I've just put the answer up. Can we check to see if you got the same? If you're done, that is. can I go to 3? Is everybody done with 2? Just raise your hand so I can wait, and I'll know whether I should wait or not. No, everybody's good. Okay, so let's look at 3. So 3, can we all, for 3, they haven't given us a diagram. Can we all draw the diagram, mark the sides, and try to figure out, am I using SSS, am I using formula 1 or formula 2? Can we all do that? What do you guys think? Can I do SAS here? What do you guys think? I'm getting one answer as a no. Is he right? Can I do I have 2 sides and an angle in between? I do have 2 sides. I have this side and I have this side. But unfortunately, the angle that's given to me is not the one in between. It is not SAS. And I definitely know it's not SSS because the third side is missing. So what am I going to do? I'm going to try to find the third. Sorry. I'm going to try to find the angle in between the two. I'm going to try to find the angle between the two. So how do I do that? How do I do that? I can use my law of sine or law of cosine. Can I use the law of sine? I think I can, because this side I have an angle and a side opposite. I have an angle and a side opposite. So which means it's going to be sine 50 degrees over 4 equals, my goal is to find A, but unfortunately I don't have the opposite side A given to me too. I don't have this also. So I'm forced to find angle C. Once I find angle C, I can find angle A, because 3 angles in a triangle add up to 180 degrees. So let's all find angle C first. Let's all find angle C first. Is everybody with me? I don't get too much response from this class, so I'm not sure if you get it. So hopefully you'll ask me if you don't get it. Right? So please find angle C. So you'll use the whole sine inverse and find angle C. Okay, this is what you should have found for angle C. Everybody okay? If I find angle C, now what can I do? I can find angle A. So I found this to be 11.041. That means I can find angle A, 11.041 plus 50 degrees equals what? Find angle A. Once you have angle A, you have an SAS situation. Please find the area of the triangle. Okay, after this I don't think you need my help. Let's finish it up. Yeah, yes, Jiral. How did I get angle C? Angle C is basically, so ignore the 1, anything over 1 is okay. So I have sine C equals, so basically I have sine C equals sine 50 degrees over 4. This is what I have, right? And then how do you get angle C by itself? You move the sine over to this side. So angle C equals sine inverse of, does this make sense? Yeah, that's how you do it. And then find angle A. once you find angle A, you should be able to use the first formula because it's an SAS at that point. This is so close. Yeah. Okay, go ahead and finish up your work. I'm putting the steps up slowly, one at a time. So go ahead and check if you got this. Normally I tell you to keep to 3 decimals, but this is so close to 119 because it's, yeah, so I just, okay, go ahead and see if you got this answer. And there's no unit given, so I'm just writing it as unit square. Yes, Josh. Well, it's not squared, it is unit squared. Squared basically means you're squaring the value. So that's why you need to put something squared. Yeah? Okay. In fact, if they haven't given a unit, if you don't put this, I'm okay with it. Because they should be giving you a unit too. The question should contain a unit. Yes, Abby.
Finding angle C, could you like cross multiply?
Yeah, that's how you find it. So yeah, so 1 multiplied by sine 50 equals 4 multiplied by sine C, and then you want to get sine C by itself, so you divide both sides by 4, and this is how you get sine C by itself. Yeah? So when you cross multiply, it's 1 times sine 50 equals 4 times sine C, but your goal is to get sine C by itself, so you divide both sides by 4, so that's how you'll end up getting sine 50 by 4. Yeah, makes sense? Yeah. And then you have to get C by itself, which that's when you do sine inverse. Okay, all good questions. Any other questions before we go on to number 4? Oh yes. So you're going to take your calculator out. Alright, going on to number 4. Again, let's go ahead and draw the triangle and see what's given to us and which formula will work, you think. So it looks like I cannot do SSS, obviously, only one side is given. I can't do SAS also because I have 2 angles but only one side. I have only one side. So I can do SAS if I can find either the side opposite 32 degrees or the side opposite 17 degrees. It doesn't matter which one, because the angle is going to be in between. I can either do these 2 or these 2. It doesn't matter which one you do. But to start with, what would you do? Can I do, does this allow law of sine? Okay, so what, before we even think about loss, what do you think you'll do? If given such a situation, what's one thing you'll find right away? Okay, go ahead, Gerald. Perfect. Whenever you're given two angles in a triangle, the first thing you'll do always is to find the third angle. So can we all find angle A first? And that will solve a lot of questions. What is angle A? Angle A is 180 minus 32 plus 17, and what is that? Angle A is 131 degrees. Is everybody okay? Now can I use the law of sine to find any missing sides or angle? I'm going to try to find the missing side. Because that will, so my missing side is going to be, I already have one side. I can either find the side opposite 17 degrees or opposite 30. So I'm going to try to find this side. It doesn't matter which one you use. I'm just going to try to find this side. So if I need to find that side, first of all, you'll start with the law of sine. So sine 131 degrees over 4 is equal to, because I'm going to find the side opposite C, angle C, I write sine 17 degrees over small c. Can we all find small c? Once you find small c, you have an SAS situation. You can find the area of a triangle. Okay, small c is, what did I find? I found my small c to be 1.55. Did we all get this? Please let me know if you didn't get this. Okay, once you find small c, now you have an SAS situation. Can we all find the area? I'm going to use the side 4, I'm going to use the side 1.55, and I'm going to use the angle in between them, that is 32 degrees. So let's go ahead and use our area triangle and finish this problem. Again, before putting this in the calculator, not a bad idea to simplify this. 4 and 2 simplifies to 2. So you're going to put 2 times 1.55 times sine 32 degrees. What do you get? Okay, I'll give you guys 30 seconds to a minute and you finish it up, and then we'll go to the next page. Yes.
So are we always considering rounds and variables?
Yeah, but mostly the test should tell you.
Okay.
Yeah. Sometimes they'll even say to the 10th. 10th means 1 decimal, right? So it will tell you, yeah. I think this one tells you to the third, somewhere it tells you. Round everything to 3 decimals. How are we doing? Does anybody have any questions? Is anybody still working on 4? Okay. Then we're going to go to a next page. Next page has a bunch of word problems, but we'll just do one of them. And then we'll wrap it up, and then I want to give you guys time to work on the review. So we are going to be working on number 7. Can you all take a minute just to read the number 7? So go ahead and read it. Yeah, so it is a triangle. Everybody got that part? It is a triangle. It has got 3 sides of a triangle, which are 65, 72, and 88. So the idea is, the question here is, how much paint do you need to be able to cover this deck? So you basically need to calculate the area, because area is the one that will help you figure out how much paint you need, because 1 gallon of paint covers 400 square feet. So how many square feet is this particular deck? So this is an oblique triangle. I don't know the height, I just need to know the 3 sides. That means you will use the Heron's formula to calculate the area of the triangle. So let's go ahead and use the Heron's formula. Just first thing is to find the semi-perimeter. Okay, so my semi-perimeter is 112.5. So go ahead and use this in your Heron's formula, put in your calculator, and tell me what is the area. So let's just do the first step to find the area of this triangular deck. Did everybody get this for the area? 2302.68. Okay, but remember that's not the final answer, because they're not asking for the area of the direct. They want to know how much paint needs to be bought. So let's go ahead and see what is going to help us decide that. It says 1 gallon of paint covers 400 square feet. So how many gallons do you need to cover 2,302 square feet? So 1 gallon covers 400 square feet or feet square. How many gallons, x gallons, will cover 2302.68 square feet? How will you set this up? You can just set it up as a ratio. 1 over x equals 400 over 2308. Cross multiply, solve for x, and that's your answer. Did we all get that? 5.76 gallons. Or since you're buying gallons, it's basically you always round it up. So you're going to be buying 6 gallons of paint. You're going to be buying 6 gallons of paint. Which makes sense, right? Because this is 2302, which is 400 times 6 is 2400. So this is close to that, 2400, just a little less than 2400. So if you're rounding it up, it is 6 gallons.